Hello, good morning. I'm discussing about classification of solids. Depending on the nature of the order of repeating unit or constituent particles, solids are classified into following three types. Crystalline solids are pure homogeneous solid substance which is composed of atoms, ions, or molecules arranged in a definite pattern with fixed geometric shape having the sharp melting point is called crystals. The crystals are packed together in a well-defined order, then crystalline solid is formed. Properties of crystalline solids, they have a sharp melting point, they have long range of order, they are anisotropic in nature, they do not have the tendency to flow, they have a geometric shape, they show cleavage property, that is when caught by a sharp tool, the surface are plane. They have characteristic heat of fusion. Anisotropic nature of crystalline solids. The anisotropic nature of crystalline solids refers to their property of exhibiting different physical properties such as electrical conductivity, thermal conductivity, refractive index, and elasticity in different directions within the crystals. Anisotropics of solids means uh, showing the different physical properties such as electrical conductivity, thermal conductivity, refractive index, and elasticity in different directions within the crystal. Ordered structure, crystalline solids have a regular repeating arrangement of atoms, ions, or molecules in three-dimensional lattice. This ordered structure causes various properties depending on the direction of measurement. Directional dependency, the variation arises because the spacing between the atoms or ions and, the type of the bonding differs along different axes of the crystal lattice, that is X, Y, and Z direction. Contrast with the isotropy in amorphous solids like glass or plastic, the structure is random and lacks long range order. As a result, this material shows isotropy, meaning their properties are the same in all directions. For example, electric conductivity, graphite is an excellent example where electrical conductivity is high along the planes of the carbon atoms, but very low perpendicular to the planes. Refractive index, calcite shows the different refractive index when light passes through it in different direction, a phenomenon called birefringence. Amorphous solids. Amorphous solids is a type of matter, solid, liquid, gas that lacks a regular long-range order within its atomic structure. The lack of atomic level or order differentiates amorphous solids from the crystalline solids, which have a regular and repeating arrangement of atoms. Properties of amorphous solids: lack of long-range order, isotropic in nature, supercooled liquids, no sharp melting and boiling points, undergoes irregular cleavage. Isotropic means the material shows the same properties in all directions. That is a characteristic of amorphous solid, but not shown by the crystalline solid. Supercooled liquids, this term applies to the some amorphous solids like glass, which lack a regular structure and are sometimes referred to as supercooled liquids. Pseudo liquids, these are also associated with the amorphous substance that shows some solid-like properties but lack of the crystalline structure. Microcrystalline or polycrystalline solids. Microcrystalline solids, also known as polycrystalline solids, are the materials composed of a large number of the small randomly oriented crystalline regions called grains. These grains are separated by the grain boundaries. Anisotropy and isotropy of the polycrystalline or microcrystalline solids. Individually, the grains are anisotropic properties vary with the direction within a grain. However, on a macroscopic scale, the materials often appears in isotropic because the Grains are randomly oriented, averaging out directional properties. It is the all about classification of solids. Thanks for watching. Thank you for your patience. That is now. Bye bye.